Prognostic research is like being a detective for the future. We take various clues, such as patient's age, medical history, and test results, and piece them together to predict the course of a disease or condition. The goal of prognostic research is to identify factors that can help us estimate how a patient's health might progress. Think of it as our way of giving patients a sneak peek into their health future. By understanding these factors, we can better plan treatments, manage risks, and provide more personalized care. Hardly a day goes by without using some form of predictions. Sports analysts forecast the outcome of sports events or the performance of individual athletes by putting together information about player statistics, team performance history, injury reports, etc. Or banks that use credit scores to assess the likelihood that the person will repay a loan and decide whether to approve or not the application by putting together a model that involves credit history, income, employment status, outstanding debts, etc. An example from healthcare research is the fracture risk assessment tool. This tool aims to predict the 10-year probability of bone fractures in individuals based on clinical risk factors like rheumatoid arthritis, smoking, alcohol, and bone mineral density. The developers of this tool have implemented it in a website where one can enter patient characteristics and obtain the predicted probability of bone fractures in the next 10 years. But what lies beneath this tool? Well, we don't have a crystal ball, but we do have data and statistical models. Today, thousands of articles have been published suggesting prognostic models for more than 200 different health conditions or outcomes. However, most of those models have not been adopted in clinical practice. The reason of this is the poor methodological quality of both the data and the analysis that were used to develop the models, the lack of validation of the models, and the lack of their reproducibility. Here on the screen, you see some of the most widely adopted prediction tools, such as the Apache score in critical care. The concept of prognosis relates to association and causation, but these three concepts are different. Association shows a relationship. Prognosis predicts the outcome, and causation indicates a direct cause and effect relationship. Researchers are very well accustomed with association. For example, people with blood type O might have a slightly lower risk of heart disease compared to those with blood types AB or AB. However, blood type alone does not predict whether an individual will develop heart disease. It is an association, but it's not strong enough to be used as a reliable prognostic factor. And also, blood type itself does not cause heart disease or protect against it. The association might be due to other underlying genetic factors that are correlated with blood type. Family history has been established as an important factor that predicts heart disease. However, family history itself does not cause heart disease. Instead, it reflects shared genetic factors, lifestyle choices, or environmental exposures. It is hypertension that is causally associated with a higher risk of heart disease. Associations can be established using simple study designs like cross-sectional and standard analytical methods like statistical tests and regression models. Prognostic research methodology is used when we are interested in making predictions about health outcomes. There are four main themes for prognostic research. Fundamental prognostic research studies the course of health-related conditions in the context of the nature and quality of current care. Prognostic factor research focuses on specific factors like biomarkers. Prognostic model research refers to the development, validation, and impact of statistical models that predict individual risk of a health outcome. Personalized stratified medicine research is a term that is used to describe the development, validation, and impact of statistical models that predict which individual or group of individuals will benefit most from a treatment. Prognostic model research starts with a clearly defined aim. We need to think about population, outcome, setting, and the end user of the prognostic model. An important step is to identify published prediction models and studies in order to be able to decide whether we really want to develop a new model or we want rather to update an existing one. Then we need to define the outcome measure and list potential candidate predictors using prior knowledge and expert opinion. We need to collect the data and consider the sample size and how much information it could potentially give us with respect to the impact of predictors. And then we need to have a strategy about dealing with missing data. Next step is to fit the prediction model using shrinkage techniques. Then we need to assess the model performance considering calibration, discrimination, and perform internal validation. We need to decide on the final model and base this decision on optimism-corrected performance measures. Then we can perform a decision curve analysis, and if among our aims we need to assess the predictive ability of individual predictors. Finally, we write up and publish our findings. We can follow the tripod statement, which is a guideline about transparent reporting of multivariable prediction models. In summary, prognostic research is about looking into the future based on the clues we have today, helping us navigate the complex world of health with a bit more confidence and a lot more knowledge. In the prognostic research course, we will dive into the world of prognostic research, a realm where data meets foresight and science meets strategy.